First one we're going to talk about physical quantities. It's going to have to be something you can measure. If all your products come out with equal type units, well, I guess it could be units. Usually it's going to be some sort of weight type measurement, pounds, using the metric system, the equivalents there, gallons, and that sort of thing. Some sort of measurement of what's in those products rather than just units, because especially with oil, they're not necessarily going to be a unit. It's going to be the same for all products. So you measure it in some sort of determinable volume, gallons or so forth. Usually use physical methods because, well, output prices are volatile. Meaning that you don't really have control. They're going to change. Very often, gas is quite volatile. It goes up and down and up and down. Product prices might not necessarily be set by the market. Call it end market. You can kind of see that in gas. The main people that set the price is what OPEC decides the price of a barrel is. And the actual supply-demand, that side is about commodities trading. It's not really related completely to the consumer buying the gas. There's some relationship. We saw that a little bit with the price of gas, but it's more that other market that's setting the price, not so much the end market of the actual consumers. So we have that problem. So we have these problems where we can't figure out the price of the products. The only way we can really allocate these joint costs is based on their physical volume. All right. So I got a little sample of work. I'm going to have one for Mikey's. We're going to go back to that beer we were making back in process costing. I changed the name of it. So, it's called a micro. Micro beer. It's a small brewery. They started off processing a single brewery. They have these initial costs, these joint costs. It goes into making beer of $450,000. So that's the initial, brewing stage. What they can get out of this initial stage is they can get a light beer, they can get a dark beer, and they can get this sellable impure byproduct that has a relevant sales price, so we're going to count it as a joint product. For $450,000, it gives them 15,000 gallons of light beer, gives them 20,000 gallons of dark, and 25,000 gallons of this impure byproduct. Basically, what happens is impure byproduct, it's that leftover, primarily the grains, but it has some liquid left in it. We need to, I guess, let dry out. But at least I know I went to a brewery tour in Portland. What they do with their grains, well, they have these cows that then get to start feeding off of them. The yeast hasn't been added, so it's not alcoholic, so you don't have drunk cows wandering around. But there was supposedly a pretty big market of selling these grains after they were through with the beer process. So during brewing, case for dark, and we give it to the cows. And we just sit it out and let the liquids dry out and give it to the cows. But we got this $450,000 that we need to allocate to these three products. The physical quantity method simply says we're going to allocate it based on what we get out of the process. So in this case, it means we get a total out of this 60,000 gallons. We simply take the proportion. So light beer, we get 15,000 gallons. We're total getting 60,000 out of this cost. So light beer make up 25% of our total production. 15,000 divided by 60. Dark beer, we get 20,000 gallons. Divided by 60. 33.133% of our output is related to dark. So 5,000 gallons of the impure means 41.7%. Step one, simply take what we get out of this process in some sort of physical quantity we can measure. In this case, gallons, we can easily measure. A gallon is going to be the same. A gallon's a gallon. Figure out our total production and break out the proportion of the three products. Then we'd simply take, physical quantity says, if light beer makes up 25% of our production, they should get 25% of the cost. Total cost $450. Light beer then should be allocated $112,500. 33.3% times 450. You do that in your calculator. And then we calculate, then the impure byproduct, since they're 41.7% of total output, they get that $187,500 in cost. Following the physical quantities measurement, we had the biggest proportion of gallons coming through the impure byproduct, so we're going to allocate the largest cost. Well, start thinking about that. And you're like, well, it really comes down to it. Those cattle farmers aren't going to pay us as much as that beer drinker is going to. Yes, the process calls for a lot coming here, but is it really fair that we're allocating the highest amount of cost? Is it really going to be able to absorb that cost? Are we going to be making mistakes later on when we try to price our light and dark beer? Not getting enough to cover all our costs? There's only going to be so much that the cow farmer's going to be willing to pay for this stuff, because eventually they can go and get other types of feed. So that's the drawbacks of the physical quantities method. If we have a product that we can't sell for, also we can't sell for very much, but we produce a lot of it, it's going to get kind of a high proportion of the cost allocated to it. So we have monetary values to help with this. Physical quantities, when we have no idea of what the final sales price is going to be or any kind of value of our products, it's our only choice to allocate the cost. But there can be limitations. You might should we really be allocating the most cost to the impure byproduct?